This is part 3 on our discussion of pH and pOH. In the previous video, I have discussed that pH is equal to the negative log of the concentration of H+. It's also similar, or it's equal also to the negative log of the concentration of hydronium ion. So again, this hydronium and H+ are used interchangeably. We also have the pOH. pOH is similar to pH, pero instead na H plus ang concentration, it depends on the concentration of the hydroxide or the OH minus concentration. Let's go back to the dissociation of H2O. This one is the simplified equation for the dissociation of H2O into ions H plus and OH minus. Again, this one is the equilibrium expression for this reaction, and we know the constant. The constant is 1.00 times 10 to the power of negative 14, and we can say this is equal to this one. Let's say we want to get the negative log of all the numbers here. We can have this one, so I just get the negative log of this one, and then this one, and then this one. So of course, the negative log of this number is equal to 14. And here we have the negative log on the concentration of H3O plus. Again, this H plus and then this H3O plus, these are the same again. So here we have the negative log of the concentration of hydronium ion. Of course, this one is our pH, right? And then this one is our pOH, the negative log of the concentration of OH minus. Again, this one is the pOH. It's equal to 14. So please remember this one. The pH plus the pOH is always equal to 14. Let's use this one in completing this table. So we have here the concentration of the H plus concentration. Again, it's similar with the hydronium ion concentration. Here we have the concentration of hydroxide ion or OH minus. Then here we have the pH, the pOH, and then here we have the classification of the substance, whether acid, base, or neutral. For the first one, given is the concentration of the hydrogen ion, which is equal to 1 times 10 to the power of negative 7. This is a familiar number because this one is the concentration of H plus in water, and of course water is neutral. And of course, in a neutral substance, the concentration of H plus is equal to the concentration of OH minus. So we also have 1 times 10 to the power of negative 7. Let's determine the pH of this one. Of course, the pH is equal to the negative log of the concentration of H plus. And here we have the given na nga to ang H plus, so we can put it here on the equation, the negative log of 1 times 10 to the power of negative 7. So this one is an easy number because it's base 10. Then here we have the coefficient is 1. We can determine that the log of this one is 7 or negative 7. So, and of course, since it's negative, so the negative of negative 7 is 7. So the pH for this one is 7. And then we also need to find out the pOH. The pOH depends on the OH minus concentration. So again, the pOH, that's very similar to pH, pero instead na H plus yung basis, the basis will be the concentration of the OH minus or the hydroxide ion concentration. Here our concentration is 1 times 1.0 times 10 to the power of negative 7. And this one is the same with this one, right? So this is also equal to 7. So the pOH here is equal to 7. And of course, the pH here is 7. This one is obviously neutral. And please remember that pH, again, the sum of pH and pOH is equal to 14. So obviously here, 7 plus 7 is 14, which is correct. Let's go to the next one. The given for the second one is the pH, which is 3.50. From this, let's find out the pOH first. Again, the pH and then the pOH is always equal to 14. So if we know the pH, again, that's 3.5, we can determine our pOH. because again the sum is always equal to 14. So to find out for the pOH here, simply subtract 3.5 from 14. So just transpose this one over here. So we have, let's open our calculator. So we have 14 minus 3.5 is equal to 10.5. So here the pH is equal to 10.5. The pOH is equal to 10.5. We have the pH, then we have the pOH. Let's find out the H plus concentration. So it's easy lang, just follow this format. We have 1 times 10 to the power of negative 3.5. So this one is the H plus concentration. Then for the pOH, the same thing, 1 times 10 to the power of negative 5. So let's classify this one. So the pH here is 3.5, that's less than 7. Again, 7 is neutral. When it's less than 7, that is an acid. And also it's based on the concentration of H3O plus and then the OH minus. Remember that when the concentration of H3O plus is greater compared to the hydroxide, this one is acidic. On the other hand, pag mas taas yung value ng or the concentration of OH minus, then this one is basic. If we look here, so we have, let's focus on the exponents here. So that's negative 5, then this one is negative 3.5. So again, this one is a negative exponent, therefore this one is a larger number. Again, it's larger when it has a lesser negative exponent. So in this case, mas taas yung concentration ng hydronium compared sa OH minus. So this one is obviously acidic. Let's proceed to the next one. The given is the OH minus concentration. So from this one, we can determine first the pOH. Again, the pOH is equal to the negative log of the OH minus concentration. Here, the OH concentration, it's given. That's equal to 2.7 times 10 to the power of negative 5. 2.7 times 10 to the power of negative 5. And we need to use our calculator. It's not the same before. Na we just copy the exponent here because it's not 1 ang naadare. So we need to actually use our calculator for this. So it's 2.7 times 10 to the power of negative 5. Then we get the log of this number is equal to negative 4.5, and again the negative log is equal to 4.6. Okay, that's 4.6. The pH here is equal to 4.6. We know now the pOH. What are the other numbers we can get from this one? Again, pH plus pOH is equal to 14, so we can use this equation. So let's use this one. Let's erase first the things here. Okay, so we have the pH here. The pH is equal to, of course, it's unknown, so we only know the pOH here, which is equal to 4.6. 4.6. Again, it's equal to 14. To find out for the pH, just subtract 14 minus 4.6. And then if you solve this one, 14 minus 4.6, it's equal to 9.4. So here the pH is equal to 9.4. And then to find out the H plus concentration, the same format, 1 times 10 to the power of negative 9.4. So this one is, the pH here is 9.4, and that's above 7. So this one is a base. And also if you look on the concentration of the H plus compared to the OH minus, we can see here that this one is greater compared to this one because again it has a lesser negative exponent compared to this one. So this one is larger, the OH minus concentration compared to the hydronium concentration, and again on this case this one must be a basic solution or a basic substance. Next, let's go to the fourth one. So here we have 7.90 the pOH. So what are the other numbers we can get from this one? We can calculate for the pH, right? So let's use this equation again. Again, pH plus pOH is always equal to 14. We can use this one to find out for the pH. pH is unknown. The pOH is 7.90. Sorry, 7.90 again, always equal to 14 to find out for the pH. Simply subtract 7.90 from 14, and that will be equal to 14 minus 7.90. That's equal to 6.1. So it's equal to 6.1. So the pH here is 6.1. Next, we can determine the concentration of H plus and then the OH minus. 1 times 10 to the power of negative 6.1. Then this one, the OH minus, that's 1 times 10 to the power of negative 7.9. If you look to the pH here is 6.1. That's below 7, so this one is an acid. Also, if you look on the numbers here, or on the concentration of H plus compared to OH minus, this one is much larger compared to this one. Again, it's larger when it has a negative, which when it has a lesser negative exponent in the scientific notation. So this one is an acid. Next, we have 3.8 times 10 to the power of negative 9. This one is the hydronium concentration, or the H plus concentration. We can determine for the pH using this equation. So we need to use this one. So this one. Okay, so here the concentration of H plus is equal to 3.8 times 10 to the power of negative 9. Let's use our calculator. So that's 3.8 3.8 times 10 to the power of negative 9. Let's get the log of this is equal to negative 8.4. Then we have the negative log, that will be 8, positive 8.4. 8.4. So here the pH is equal to 8.4. Now we can determine the pOH using this equation. So erase. So here the pH is equal to 8.4. Then the pOH is unknown. Again, always equal to 14 to find out for the pOH. 14 minus 8.4. Then use your calculator. 14 minus 8.4. 14 minus 8.4 is equal to 5.6. We have 5.6. The pOH here is 5.6. Then for the OH minus concentration, 1 times 10 to the power of negative 5.6. So here the pH is greater than 7. It's 8.4. This one must be basic. Must be a base. And also if you look on the concentration of OH minus compared to the H plus, this one is greater. Sorry. Negative again 5.6. This one is larger, right? That's negative 5.6. Then negative 9. This one is much larger compared to this one. So that's the answer for these items.